All right, let's dive in and demystify a fundamental part of Java that can seriously clean up your code and make it way easier to read. We're talking about the switch statement.
You know that feeling, right? You need to check one variable against a whole bunch of different possible values. And before you know it, you've written code that starts to look, well, a little bit out of control.
I'm talking about this right here, the long cascading ladder of if-else-if statements. I mean, it works, don't get me wrong, but it can get messy and fast. It becomes really cumbersome and just plain hard to follow, especially when you start adding more and more conditions.
So let's take a super common task. You've got a number, let's call it n, that could be anything from 1 to 7. Your job is to print the right day of the week. Using if-else, you end up with this long chain. If n is 1, print Monday, else if n is 2, print Tuesday, and on it goes.
But what if I told you there's a much more elegant, a more structured way to handle this exact scenario? Well, there is. It's called the switch statement, and it was practically designed for this kind of multi-way branching. Just look at the difference here. On the left, you got that familiar, clunky if-else code. But on the right, the switch statement. See how much cleaner that is? It's so clear about what it's doing. We are going to switch our logic based on the one single value of n. At its core, a switch statement just takes one variable and checks it against a list of constant values that we call cases. Fun fact, older versions of Java were pretty picky about what you could use here, but modern Java is much more flexible. So, when it finds a match, it runs the code for that case. Simple, right? Well, there's a catch, and it's one that trips up a lot of new developers.
Yeah, this is where things can get a little weird. The switch statement has this specific behavior that, if you're not aware of it, can lead to some really confusing bugs. They call it the fall-through trap.
So let's think this through. We've got our switch statement, and we pass in the number 2. Logically, you'd expect it to find case 2, print Tuesday, and be done with it. So take a second. What do you think is actually going to happen?
Right. The logical expected output would just be Tuesday. That's what our if-else chain would do. It just makes sense.
But look at this. The actual output is Tuesday, followed by every single other day of the week. What is going on here? Now, this isn't a bug in Java. Believe it or not, it's a feature, and it's called fall-through.
So here's what's happening. By default, when a switch statement finds a matching case, it executes the code, and then it just keeps on going. It literally falls through and executes the code in all the cases below it, no matter what.
Okay, so how do we stop this crazy fall-through behavior and make the switch actually do what we want it to do? The solution is simple, and it comes down to 2 little keywords, break and default. It's really just a simple 2-step process. First, at the end of each case's logic, you add the break keyword. Think of it like a stop sign. It tells the program, hey, we found our match, we're done here, get out of the switch block now. And second, we add a default case, which is basically our safety net for everything else.
And you can see the fix right here. Before, without the break, the code just flows from case 2 right into case 3. But now, on the right, after we print Tuesday, we hit that break statement and bam! Execution stops and jumps straight out of the block.
And just like that, with one tiny keyword, our problem is totally solved. Now when n is 2, it matches case 2, it prints Tuesday, it hits the break, and it immediately gets out of the entire switch block. Perfect.
Okay, so the fall-through problem is fixed. That's great. But there's one more little loose end we need to tie up. Our cases only handle numbers from 1 to 7. So what happens if a user types an 8 or 0 or any other number that isn't one of our cases? As it stands, nothing. The program would just silently skip the whole thing.
And that is the exact reason the default case exists. You can really think of it as the final else in an if-else chain. If none of the other cases match the input, the code inside the default block is what gets executed. It's our catch-all.
And here it is in action. Right after our last valid case, case 7, we add our default block. Now if the input is 8, the program will just skip all the numbered cases, land on default, and print a helpful error message. Our switch is now officially robust.
So now that we know how to build a proper, robust switch statement, the really big question is, when should you actually choose to use one over a classic if-else chain?
This table really breaks it down nicely.
Your if-else chain is your go-to for more complex logic, like checking ranges, is x greater than 5 and less than 10? But the switch statement, it is the absolute champion for readability when you're just matching one single variable against a bunch of specific constant values. It's also often faster because the compiler can sometimes optimize it into something called a jump table, which is way more efficient than checking every single condition one by one.
So let's just recap the big points. Use switch to clean up those long, messy if-else ladders, but only when you're checking a single variable. The most important thing, always remember to use break to avoid that fall-through trap, and use a default case to gracefully handle any unexpected values. So I'll leave you with this little challenge. Next time you're coding, take a look through your own projects. I'll bet you can find a messy if-else chain somewhere that's just begging to be refactored into a clean, elegant switch. I hope this helped clear things up.